Hello ARRL members and QST readers. This video goes with the January 2022 issue of the Ask Dave column in QST and is just a little further information on the question about autotransformers. I'll briefly refer to the figures that are in that article, and then we'll take a look at an actual balun. So let's do that. This is what I started with. This is a generic transformer, a toroid core, 5 turns, 25 turns. There's no actual electrical connection between the two sides, but this is a balanced input, this is a balanced output. Now, we can, if we bring the coax out here to some spot in here and then ground this on this side, this can still be a balanced output. So you got a balun. Another way you can make this output balanced with reference to ground is by attaching the center to ground. Okay. And then there is the autotransformer method of having a single core and a single winding. Now, since the voltage goes up here as a percentage of the windings, we can use that. Now, this is the schematic for a standard balun, and one I'm going to show you here. We're going to use the same core for both the primary and secondary. Okay, tap A in the middle is going to be grounded, which is very much along the ideas of what we had here. The center grounded so that this could be balanced around ground. Okay, and then the plus comes in here, touches the start of the coils and also comes out on the other side, and usually that side is marked with plus so you know which one does that. And then this down here, this voltage will be twice what the input voltage is. It's called an autotransformer. Okay, and this output is balanced with respect to ground. Let's take a look at one of those. This is by Balun Designs. You can get these at balundesigns.com. It's a Model 3 4-to-1 tuner balun, 5 kilowatt. And if we look back at this, if this is the same number of windings here to here, it'll give you twice the voltage and half the current, which works out to dividing half the current into the voltage. You get 400 ohms, or I'm sorry, 200 ohms. Okay, so let's take this apart. And here's the coax coming in. Okay, the ground on this side goes over and connects to the middle of the windings. The input comes over here, connects to the one marked plus, and the windings go this way. Okay, now note there the two wound together, and the center one, okay, goes out over on this end and is, you can't see it in here. Here we go. If you look right here, you see the winding connected to the plus and the center conductor connected to the plus. All right, and then this winding goes around, actually twice, around the core, and then there is the center of it, which is connected to the ground side over here. And that is exactly this schematic, where you have the input touching the end of the core and going to something marked plus. The center, the ground point, coming over here to the center of the winding. Okay, And then the rest of it, this part over here, is connected to, get all the light we can get in there. This right here, if you look very, very carefully back in here, you can see a winding from the coil coming over and connecting here. Now, you might also note that this thing is built like a truck, and you can put full legal limit power through this. In fact, it says it will take up to 5 kilowatts. You can see the yellowing, that this was on the bottom. This was up against a board, and this is what the sun was on. And you can see that the sun, UV, does affect this, but it was years in the sun and did not warp or do anything that shouldn't. So you've got unbalanced here, 50 ohms. It's a 2-to-1 winding. So the output here is the square of that. 4 times the input, 4 times 50 is 200. Sometimes people think that this is 400 ohms. It's not, it's 200. And you want to get a balun with a different winding sense if you need higher. If you're going to do like 49-to-1 for an end-fed dipole, you're going to have a completely different design. By the way, the American Radio Relay League sort of got into the kit business a few years ago by providing a little MFJ 2-watt transceiver kit with a book with all the instructions and a lot of stuff about QRP. Well, they've come up with this new kit, which I haven't put together yet. But this right here is going to be the balun. Okay, it's got the parts inside. We're going to make this from scratch, okay? And so we're going to make an end-fed dipole. And we'll do this with all the steps out. And here are the, advertising. Here are the other pieces, the actual wire and stuff like that. So we'll build that in a future video. And then it'll have a balun. This is a balun, same concept, but it will be a 49-to-1 balun instead of a 4-to-1 balun, which gives you 50-to-200. Okay? So you can get baluns at different ratios. If, for example, you want to connect coax to 450 ohm ladder line, or more appropriately called window line, you need a 9-to-1 balun to get that 50 up to 450. Okay? So the ratios do mean something. Whether it's a voltage balun or current balun means something, but this is a voltage balun, by the way. So there you have it.